Hello viewers, in today's class I'm going to be considering complex numbers. Of course we know that a complex number is any number of the form z equal to a plus b I, where we have that where a and b are real numbers, where a and b are real numbers, while I is the imaginary number. So we have that a complex number is represented in this form, a plus b I. The I is the complex number. So we have that a and b are the real numbers, while the I, or the complex, I is the imaginary number. So for instance, if we have this, this is basically introduction to complex numbers. So if we have that, if we have x squared plus 1 equal to 0, and we have to find the value of x, for instance, we are going to move on to the right hand side. So we have x squared equal to minus 1, and then to solve this we can say find the square root of both sides. And so when we do that, we are going to have x squared equal to square root of minus 1. Of course, if this cancels out, okay, we are going to be left with that x equal to square root of minus 1, which is equal to I, because square root of minus 1 is a complex number. That is, square root of minus 1 is a complex number. So in this sense, you can say that I equal to square root of minus 1. And so with this relationship, you can use this relationship to, actually prove, find I squared, I cubed, and so on. You can use that relationship to determine quite a lot of things. For instance, if I say that I, okay, I'm writing it. If I say that I equal to square root of minus 1, and then I want to find the value of I squared. So this means that I squared definitely will be I times I. This is what it means. I squared will be I times I. So if I squared is I times I, then this is the same thing as saying square root of minus 1 times the square root of minus 1, because I is square root of minus 1 times another square root of minus 1. So this is the same thing. If you look at this, the square root of minus 1 can be expressed this way: minus 1 all raised to the power of 1 over 2. And this one also can be expressed as minus 1 all raised to the power of 1 over 2. Okay, so since we have that expression that way, it means from, this is minus 1, it means from the law of indices, since the base we have is the same, we can add the powers because we have multiplication here. Since we have the same base, we can add the powers because we have multiplication. So we can take the base, which is minus 1, equal to 1 over 2 plus 1 over 2. And so this will give us minus 1 raised to the LCM of 2 and 2 here is 2, so we have 2. 2 here dividing this 2 here is 1. 1 times this 2 will give us 1 plus 2 here dividing this 2 is 1. 1 times 2 here will give us 1. So this will be equal to minus 1 raised to the power of 1 plus 1 is 2 all over 2. So if you cancel out, you have 1, 1. So this will be equal to minus 1 raised to the power of 1 over 1, and 1 over 1 is also minus 1 raised to the power 1, which is the same thing as minus 1. So this means that I squared will be equal to minus 1. So anytime you are solving questions on complex number and you find I squared, it means you write it as minus 1. For instance, if you have maybe you're solving something and you have 6I squared, this will be the same thing as saying 6 times minus 1, which will give you minus 6. So that is what this implies. So actually you can use this relationship of I equal to this and I squared equal to this to evaluate I cube, I raised to power 4, I raised to power 5, etc. And again, still under introduction on complex numbers, if you have z to be equal to a plus bi, and assuming, okay, if this is z1, okay, z is equal to a plus bi, and your z1 will be equal to a1 plus b1i, and your z2 will be equal to a2 plus b2i. Of course, with this relationship, you can only say that z1 is equal to z2 when you have a situation where z1 is equal to z2 when you have that a1 is equal to a2 and b1 is equal to, where you have that a1 is equal to a2 and b1 is equal to b2. So if you have a complex number of this form where z is equal to this and z1 is this and z2 is this, you can say that z1 equal to z2 when this condition is met, that a1 equal to a2 and b1 equal to b2. So lastly on introduction to complex number, let's consider this. If we have a plus b, if we have say a plus bi into a minus bi, okay, and we have to expand this. So we have a times a will give us a squared plus, a times minus bi will give us minus a bi. We have plus here, plus bi times a will be the same thing as plus a bi, and then bi times minus bi will give us minus b squared I squared. Okay, and of course we have this to be a squared. This minus abi plus abi will cancel out. Markers. And so we are going to be left with minus b squared I squared. But we should recall that I squared equal to what? Minus 1. We've done that. We've established this relationship. Therefore, our a squared minus b squared into minus 1. So where we have I squared, we now introduce minus 1. And so this will give us a squared minus b squared times minus 1 will give us plus a squared. So which is the real part. You can say the real part or the real number. So if you express this, you're going to arrive at this. So basically, viewers, that is a brief introduction into complex numbers. And in my next video, I'm going to be solving problems on addition and subtraction of complex numbers. I'm going to be solving problems on scalar multiplication of complex numbers. I'm going to be solving problems on division of complex numbers. We are going to look into the movie